work order, what the changeover time is. A lot of machines maybe require some changeover to get it ready for the new product, what quantity you want to run. And the interesting part about this is up here on the finish time, it calculated based on the changeover time and the quantity, it calculated when the estimated finish time is. And that takes into account breaks or your workday, you know, what your typical workday schedule is. Then we have the operator screen, and you know, keep in mind these screens are just kind of the what you get with the product. You can come in here and modify these screens. So if you wanted to put other items quality information in here, or you wanted to put start stop for your line, or whatever else you want to add to these screens, you can modify them. This is just kind of our sample template here. It shows you know, the current product being run. It allows them to control the run. Downtime reasons. It will allow them to come back in here and override. So if the operator press stop, you can go in there and they can select a downtime reason of why they press stop. They can enter in notes down on the bottom, and so on and so forth. We have just a quick, you know, brief screen that shows some charts, just kind of so the operator can see at a glance without putting much effort into it how it's going, and other people can too. We have an analysis screen. This is where most of you're looking back over history to see what has happened. So in this case, like here, we have bottle waste. You can create your own queries. I'll show a little bit about that. But bottle waste, what's interesting about that is that's like a user-defined data point that we're tracking. So it's very easy to add these data points. And it might be cardboard manufacturer, or it might be film manufacturer. And you'll be able to look at your efficiency by those different user-defined data points. We can take a look at, you know, OEE by operator. We can look at that in different ways, in bar charts, in tabular form, production count by hour. We have line charts. We have a simulator, so it has a very consistent production rate, but you would see your actual production rate there. If I was to create my own, I can come in here and select what I want to view, and select OEE. I want to compare maybe first by operator. No more exciting screen here. First by operator, then I can come in and say, oh, I want to buy operator by shift. Say compare by multiple things. I can come in here and say, I just want to look at it for line 1. And it's that easy to drill down and see what you want. At the bottom here, we have a date range that you can easily select the date. And that is pretty much the user screens that we have. And keep in mind, these are all controls that using the standard vision screens or windows and just plopping down controls that come along with the OE downtime and scheduling package. Next, I'm going to go into the designer. For those of you who have used Ignition before, this will look familiar, with the exception that we now have a new item up here called production. And this is where the production model is defined. So you can define your enterprise, you can have your site, you can have multiple sites. In fact, the analysis back there, you will be able to query and analyze across multiple sites, physical sites. Different production areas also within your plant. So you might have packaging and you might have cracking or brewing or what have you. To add a new line is simply selecting the new line menu. You can rename it. Whoops. Added a cell also. So now we have a new line 3. And then once you add that new line, a whole wealth of information starts being calculated for you. I didn't save it. That would help. Okay. There's line 3. Now we have a whole bunch of tags that are available. So like here's OEE. We have the actual finish time of the run or start time. We have, the product code for that line that's being run. We have production rate by hour and by minute. So I just wanted to show all the things that are happening behind the scenes just by simply adding a line. Same is true for a cell and such. Once you have the line in there, then you can configure it. And this is where, like additional factors, where I have operator and bottle waste that I showed you over in the analysis screen. This is where it's defined. So it's just simply adding that. Your OEE information is here, downtime information. So all your downtime reasons, whether the operator can select that downtime reason or record downtime. Schedule information, so your morning break, afternoon break, and then, it's inheritable. So if you have a piece of equipment that's different, you can override that, and so on and so forth. So that concludes the demo here. And at this time, it's my pleasure to introduce Bill Clark, who's in charge of the MES application for Diamond Foods. Diamond Foods has been a beta tester for us of the OEE. Okay, sorry about that, technical difficulties. But Bill's going to give us an end user's perspective on MES.
Thank you, Tom. As most of you as integrators know, the one thing that plant management is always looking for is to get the most current information that possibly get access to make the decision that is going to streamline their business. At Diamond, our management has been in search of that, and I've been assisting them, starting with implementing Ignition. We started with the Inductive Automation software a couple of years ago. We've been bringing real-time information and historical information to management desktops over the last couple of years. We're tied into probably 30 different systems in our plant. The plant is an older facility that's evolved since 1956. So we have a variety of systems and evolutions of equipment that we're tied into. But right now, I probably have 30 different users on the system that span maintenance, operations, quality control, and management. One thing that management needs is they need access to resource utilization and production reporting so that they can plan capital projects, identify potential savings, schedule production resources, schedule maintenance activities, and even focus training efforts. One of the problems that you typically run into is that information is based on operator logs, inventory report information, maintenance logs, and this is information that's manually input in most plants into a custom database or spreadsheets, and there's an inherent disadvantage to that. The data tends to be incomplete. Some of the information is conflicting because it's influenced by operator and maintenance opinions, and they don't get the information right away. It's stale. Typically they're seeing information that's 24 hours old or more. So the one thing that we're trying to do with the MES is we're trying to improve on those shortcomings. We're trying to get management the actual statistical data directly from the controllers. Certainly there will be some operator log entries that's going to support that, but the management will be able to see more of what's actually going on based on what the controllers are telling, the PLCs are telling. We're also trying to reduce the key punch time in the plant. We expend hundreds of man-hours every year to get this data input and maintain these reports for management. We want to reduce that by letting the PLC do a lot of that work, which it does very well, and let the software record it and present it, which it does very well. We're also wanting to provide managers, supervisors, technicians, and operators with near real-time actionable data. We want to be able to identify a situation before it's 24 hours old. We want to be able to identify it quickly and take action before the shift is over. Also, we would like to be able to get more flexibility out of the reporting. We'd like to be able to make comparisons, as Tom showed, and we'd like to be able to see greater detail in the information that we get. That drill-down capability that the software provides us is just invaluable when it comes to trying to get to the root cause of a problem. I've got an example to share. I was working with one of our production supervisors to acquaint her with the software. And within an hour of starting a production run, we were able to identify a situation where the filler was being occasionally starved. The scale feeding the filler wasn't tuned properly. Ordinarily, this is a hard thing to identify when you're standing out at the line as an operator. But when we were looking at the thing, at the reports in the software, we were able to see that our actual rates, our actual production rate was falling short of target. We were seeing low OEE, and when we started drilling down into the downtime issues, we were able to see a very high frequency of the filler waiting for product. And over the course of the first hour of operation, we had accumulated 5 minutes of downtime. We went out to the line. We were able to work with the operator to tune up the scale, eliminate the problem, and in essence, we were able to produce 4 more pallets of product that shift than we would have if that would have gone unnoticed. It also was able, it gave us an indicator that that operator needed some additional training to recognize that situation and how to resolve it. So this was done an hour into the shift rather than waiting for 24 hours after the shift was over and then go back and try and do something about it. With our historical reporting techniques, it would probably not even gotten into the logs. So the management would have just seen a low production rate and really no reason for it. So these are some of the advantages that we've seen with the software, and we think that we think it's very important to our business and helps our management, and certainly helps me and the other supervisors at the plant.
Thank you.